So you should be able to solve this problem and try to work it out by yourself. I'm recording the answer here in case some of you need some extra help. So formulation is A minus Ri multiplied by your eigenvector, which has two entries, x1, x2, is supposed to be 0, 0, right? So when we try to carry out my calculation, you can either memorize the formulation or you do the calculation. So you want to make sure the determinant of A minus Ri is supposed to be 0. That is to say your -5, -173, multiply the R times I, which is R times I, which is subtracted from the diagonal entries. So what I'm going to end up with is -5 minus R times 3 minus R minus 7 times -1. And if I were to carry out my calculation, it's supposed to be R squared. And then I have -5 and 3 together, it's -2. So minus -2R, add to 3 times -5, which is -15, minus 7 times -1, which is +7. So I have R squared plus 2R minus 8 being 0. You can, like I said, memorize the formulation as R squared minus A plus D, the diagonal entries, A, B, C, D, right? And then plus AD minus BC equals 0. My bad, I forget the R. So this is the determinant of the A. This is what we call the trace of the matrix. It's adding the diagonal entries together. But whatever makes it easier for you to memorize the formulation, right? Start from scratch, carry out the calculation, or memorize the formulation. Either one works. It gives you the same equation, and you're gonna say it's R minus plus 4 times X R minus 2. So R is -4, R is 2. So I'm going to end up with two eigenvalues. So corresponding to the first eigenvalue, -4, my A minus Ri becomes A minus -4 minus -4. So you only put it on the diagonal entries because the I matrix only have input on the diagonal entries. All the off diagonal entries, every other entry will be 0, so we can ignore those. And multiply x1, x2 is going to be 0, 0. So I end up with -1, -177, and x1, x2, 0, 0. That's supposed to be the same. Only the first row is helpful because the second row is going to be repeated. So I have -x1 minus x2 equals 0. If you were to let x1 be 1, then x2 must be -1 for this equation to be true. So for -4, your corresponding eigenvector is 1, -1. And like I said, if you had chosen this being 2, you're going to end up with -2. So this multiply any scalar is going to be mathematically equivalent answer. And similarly, if R were 2, with the other answer you found, you subtract it from the diagonal entry. So -1, 7, that, 7, and I have 3 minus 2, which is 1. And multiply x1, x2, you end up with 0, 0. You only need to read one piece because the other one is repetition. So you have -7x1 minus x2 being 0. If you were to write the other one, you're going to end up with 7x1 plus x2 is 0, which is the same equation multiplied by -1. So mathematical equivalent. You could have said, I'm choosing x1 to be 1. And therefore, I'm going to end up with x2 being -7. So the corresponding eigenvector of R being 2 is 1, -7, right? So that's why I had my answers like this and like that. So along the same line of thinking, you could have tried to solve the second problem. Like I said, I'm only trying to provide you with a way to get the answer. Please stop the video, solve it yourself, and see if it matches what we have here. So I'm going to have B minus Ri times x1, x2, which is supposed to be 0, 0, right? You can use the formulation directly, which is r squared minus the diagonal entries add together, 2 plus -1, and then plus the determinant. So 2 times -1 minus -2 times 0 being 0. So you have r squared minus r, and then -2. So you end up with r minus 2, r plus 1. So you end up with r being 2, r being -1. If r being 2, you subtract it from the diagonal entries. And then you have x1, x2 is supposed to be 0, 0. So what you end up with is slightly interesting. You end up with 0, 0, -2, -3, which multiply x1, x2, and it's 0, 0. So the first one actually is not giving you any information. 0 times x1 plus 0 times x2 is 0. So this entry gives you nothing useful. So that's why in this case, you're going to have the second row multiplying that, right? Because the first row, once you multiply them together, it's 0 times x1, 0 times x2. There's no information at all about x1, x2. You can't solve it from it. So you have negative x1 minus 3x2 is supposed to be 0. You use this multiplied by that, so it's negative x2, x1. -3x2, and you add them together. And in this case, if you were to let x1 being 3, you could get x2 being -2. And of course, you don't have to choose x1 being 3. I'm only trying to make my numbers pretty. You could have said x1 being 1, then you're going to end up with x2 being -3/2. So bottom line, when r is 3, your corresponding eigenvector is the scalar multiplication of this particular vector. And I can try it again when x is -1, my matrix between 2 minus -1, 0, -2, -1 minus -1, which is 0. You have x1, x2, which is 0, 0. So when I multiply things out, I have 3x1 plus 0x2 being 0. That is to see 3x1 being 0. That means x1 is 0. I have no requirement for x2 at all. You could have chosen x2 to be whichever number you like. So you can end up with 0, 1. And you say, why do I choose 1? Well, you could have choose 2. So you could have get 0, 2, or you could have get 0, 10. They are all a scalar multiplication of 0, 1. We said your answer, they are mathematically equivalent if it's scalar multiplication of one another. So this is gonna how it's gonna work out. Hopefully it's helpful and you get comfortable with how to find eigenvalues and eigenvectors of a 2 by 2 matrix based on what our discussion here.